Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is XOR queries of a subarray. Okay, so you will be given an array of positive integers, and you will also be given another array queries in which each entry in this particular array will be representing the range in terms of indices between which you have to return the uh, answer of the query. Okay, so for each entry you have to compute XOR of elements from left to right index. Okay, so the XOR of the whole subarray. So for example, if this is the given array to you, let's say this is the input. Let's take both of the arrays, the given input array and the query array also, which will also be the input, by the way. So let's say this is the input. So if you want to process the very first query, then you have to do the processing like this. So let's say these are the indices of the array. Then from the 0th index to the first index, you will be doing the XOR of all the elements. Okay, so 1 XOR 3. Okay, or if you want, you can denote XOR with this symbol. Okay, so 1 XOR 3 you will be returning, and let's take another query. Okay, let's take this one. So from 1 to 2 you have to do the XOR. So XOR of 3 and 4. Okay, you have to return basically. So this is what this is how you can you will be processing the queries that is given inside this queries array. Okay, so these entries are just indices. Okay, so let's move back to the problem statement. Then you have to return an array answer where each entry in this answer array is the answer to the ith query. Okay, so this answer array and the queries array will be having the same length, answer or result, whatever you may want to call it. Okay, so and each entry in this particular answer array will be corresponding to the query in that particular index position in the queries array. Okay, so before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of the array that is given to you and the queries array will be of order 3 into 10 raised to power 4. Okay, and each entry in the first array or the array other than the queries array will be of order 10 raised to power 9, and each entry in the queries array will be of size 2, indicating the left and the right indices inclusive, both inclusive, between which you have to perform the XOR operations of all the elements in the first array. Okay, this particular array. And the last constraint is that the length, the range of these or the values of these right and left values in each entry of the queries array will be well within the range of the indices of the first array, which is this array. Okay, so you need not to worry about the ranges or doing checks for ranges, whether the range is uh, within valid index range of the first array or not. Okay, so these are the constraints. So let's think of an approach. So the very first approach that came to my mind after reading this problem statement was, basically I was familiar with the concept of prefix sum. Okay, if you are not, then I will be explaining it. So see, there are certain properties of XOR that you must be aware of. The first property is that if you do XOR of a number with itself, it becomes 0. Okay, so this is property 1. And another property, although it may not be directly applied to the problem, but XOR of a number with 0 becomes the number itself. Okay, so these two properties will be sufficient for letting us use a technique called prefix sum here. Okay, so basically, if you are not familiar with this prefix sum technique, then although I will be explaining it here also in a brief, but I will also provide link of an article explaining it in detail. Okay, so please do check that article, whose link will be provided in the description box. So anyways, what we do in prefix sum is, let's just forget about the XOR operation for a while, and let's just think that we have to do, instead of XOR, summation of things. Okay, so prefix sum is nothing but you can also call it running sum. Okay, so what I mean to say is, let's take the first array itself as our input. So 1, 3, 4 and 8. Okay, and let's generate a prefix sum array for that. Okay, so this was your initial array, and let's mark the indices 0, 1, 2 and 3, and this is the prefix sum array. Okay, it will be of same length as with the original array. So if you are at the very first index, okay, so let's say you will be having a sum value initially, or sum value will be 0. If you are at the first index, you are seeing the very first entry and your sum value is 0. So adding your first index value to the sum value, okay, so it becomes 1. So you entered it into the prefix sum array. Okay, then comes uh, thinking of entering the second entry in the prefix sum array. For that, what we will be doing is, whatever value was present here, or whatever was the value of your current sum value, you will add this particular entry value to it. So 1 plus 3 will be 4. Okay, so just like this, you will be doing the operation. So next time it will be 4 plus 4. Okay, these two. So 4 plus 4, 8. Okay, so next time 8 plus 8. Okay, similarly it will uh, be going on. Okay, and 8 plus 8, 16. Okay, so this is how you will be approaching for the prefix sum, or you can say running sum. Okay, and although this sum variable was not required, I was using it just for making you understand what does I mean by this running sum. Okay, so you will be taking the previous value of the prefix sum and adding it to the current value of the array. Okay, this particular array. So as you can see, this was the previous value. If you are making trying to add entry for the second index, then you will see what was the value for the first index, or one previous to that, in the prefix sum specifically. Okay, it was 4, so 4 plus 4 become 8. Okay, similarly here 8, and previous value was 8, so 8 plus 8 becomes 16. Okay, so this is what prefix sum is. And here, although we were doing addition, but only difference in this while we were be applying this particular technique in this particular one, will be that instead of addition operation, we will be doing XOR operation. Okay, so instead of 1 plus 3, this operation will change to XOR of 1 and 3. Okay, so now let's try to understand why we are doing that, and what kind of leverage we will be having if we have this prefix sum ready with us. Okay, so let's try to understand that. So see, let's say instead of these values, the values in the array are, let's take alphabets X, Y, okay, and Z and A. Okay, these are four entries. So you want to find the prefix or XOR of this much. Okay, so somehow you want to have XOR of this particular portion, and let's replace these also with the, or I think it's fine. So what you will be doing is, see, somehow you want to nullify the effect of all the entries still here. Okay, and to nullify the effect, this property will come in handy. Okay, if you do the XOR of a number with itself, it becomes 0, and essentially its effect on rest of the XORs will be nullified. So what I mean to say is, let's say from 0 to index 2, you are having a certain XOR, okay, and that XOR's value is A, okay, and from index 0 to 1, you are having a certain XOR, and that's XOR's value is B, okay. So in this particular A, this B must have also been uh, counted, because you must have been doing something like this. Okay, XOR at the 0th index, then XOR at the first index, then XOR at the second index. Okay, so for this particular one, this might have been the process of getting the value of A. Okay, okay, and then what you will be doing here is, see, for getting the value of B, you will be doing XOR of this much. Okay, so for B it will be, let's change color here. Okay, this. Now see, if you take these two kind of XORs, okay, that you are doing, and do XOR of both of them with each other, then these values will be cancelling out. Okay, because a values XOR with itself cancels it out or makes it 0, and zeros XOR with any number result in the number itself. So you will be only left with this particular value. Let's change color here. So this much will be left for you. Okay, which is essentially what you were looking for. Not exactly. I just took an example to see, to show you how things can be cancelled. And if you were looking for the answer of just uh, if the query was something like this, left is equal to, let's say, 2, and right was also equal to 2. So in that case, you will be having your answer. So what you did, from 0 to 2, you find out some value of XOR. Then from 0 to 1, you cancel the value by doing this XOR of this particular one with the previous one. Okay, and only thing that was left was your desired value. So in a way, the formula becomes that if you are having this prefix, let's remove this sum, or let's take a fresh slide for the discussion. So you, instead of prefix sum, you will be having prefix XOR. Okay, the only thing that will be replaced in that logic will be that you will be using XOR operation. Okay, now let's say you are having that array and you want to find XOR of this query left to right. Okay, so what you will be doing here is, firstly, uh, you should be having the value of XOR at the rightmost position. Okay, so prefix XOR of right, then you will do the XOR of, so this is similar to what we were doing here. So let's consider this was your right. Okay, so see, this was the right value. Okay, so then you will be seeing what is the one value previous to the left. If it is -1, then you will not bother, because you are anyways doing, that means that left was 0, so you are anyways having your answer. Okay, in that case, so there will be a conditional check. If left is greater than 0, then you will be seeing what is the value of prefix XOR just previous to the left. Okay, so let's say the left was here and this was right. Okay, so you will see what was just one previous value, this value, which will be left -1, or the index which will be left -1. If left -1 happens to be greater than -1, which will only happen if left is greater than 0, in that case you will be returning, basically I am using a ternary operator here, so prefix of left -1. Okay, so this is what we were doing here. See, left was 2, which is obviously greater than 0. So what will be the one previous entry before that? That will be 1. So prefix XOR of the first index. Okay, so that is what we are doing here. Otherwise, if left is equal to 0, then you will be saying, okay, we are just fine. We do not have to do any elimination of the subarray that is unwanted. The whole thing is wanted. Okay, because if left is at 0th index, then you will be wanting this whole chunk, this particular one. Okay, let me change color here. So you will be wanting this whole chunk, and no elimination or removal of unwanted part is required. So in that case, 0. Okay, and why 0? Again, I will tell you that this property is in work here. So XOR of 0 with any number becomes that number only. So that's why. Okay, so this is the whole, you can say, logic corresponding to this particular query. You will be storing this particular integer that you will be getting into the result, or you can say answer. Okay, so let's see that in implementation, and things will be more clear to you. And let's take the code to the board for that. So this is the implementation. Okay, so the very first thing that you will be doing is, you would be wanting to have that prefix XOR array. Okay, and as I already talked about uh, the similarities between that prefix sum and prefix XOR, the only difference being that instead of plus operation in that prefix sum, in prefix XOR you are using XOR operation. Okay, so this is XOR. instead of plus or sum. Okay, so if it is the very first entry, then you are not having any entries prior to it, so just entering the whatever the value is inside this array, okay, at that particular index. And if it is not the 0th index, or it means that you are already having some entries in your prefix XOR array prior to that, then you will be seeking one entry prior to the current entry that you are trying to make, and then you will be doing XOR of that entry with the current index's value in the array. Okay, this is the process that we have just discussed. Okay, this particular process. So for example, if it is the first entry, then anyways we are not having anything prior to it in the prefix, and this will be not the prefix sum this time. This will be, and let's clear the code so that you do not have any confusion about what I am doing here. Okay, let's remove all this. So see, if it is the first entry, then adding obviously the only uh, the value in the array corresponding to that index. And then if it is not the first entry, you will be doing XOR of 1 and 3. So basically this will be entered here. Okay, next time when you will be taking care of entering this one, you will be doing XOR of 1, 3 and 4. Okay, whatever this value was, let's say this was x. Okay, so you will be doing XOR of x and 4. Okay, and you will be placing it here. Okay, so this is what we are doing in the code. Okay, and then after that you will be start answering the queries that you are having. Okay, and storing the results in the results array, or you can name it answer also, so whatever is your preference. Then this index is just for the sake of helping us to enter the values of the queries in this result array starting from the 0th index. Okay, and as I mentioned, the results and the queries array will be having same length, so that's why we are taking a fixed array of that size, and then we are processing the queries one by one. So left index and the right index, between which we have to do XOR of all the entries in this particular array. Okay, so prefix XOR array is helping us to do that operation in order of 1 time complexity. That was the whole point of using this prefix XOR array. Otherwise you would have done it in a quadratic kind of time complexity, and as per the constraints that were given to us, the 10 raised to power 4 something, it would have led us to time limit exceeded, okay, error. Okay, because only there is a limit of operations, basically 10 raised to power 8 operations. If the number of operations done by your program or required by your program to solve a problem are well within are less than this particular range, then your solution will be accepted. Otherwise you might get a TLE and your solution might not be getting accepted. So that's why we do a trade-off here, trade-off between space and time. So we use some space in order to save some time. Okay, so that space was being used for making this prefix XOR array. Okay, anyways, let's not dwell much deeper into that thought, and let's come back to discussing the implementation. Okay, so prefix XOR array, uh, the right entry, the formula that we just derived. Okay, so this is what we will be doing in case you will be wanting to have, if left is your 1 and right is your 2. Okay, this is your left and this is your right. So you will be wanting to have prefix XOR of, okay, 2 minus whatever is on the left side of your left entry. If it is obviously not 0, left is not 0, so left was not 0, so prefix XOR of, not minus exactly, since we were doing XOR operation, so we will be doing XOR here. And yeah, so XOR of left minus 1, so 1 minus 1 0, so effect of this much portion will be nullified. Okay, this will be gone, and you will be left with only with this. Okay, after doing this particular operation. Okay, so this is essentially what we are doing here. If left is 0, then saying that we need the whole chunk, what is we will be wanting to preserve whatever inside is stored in that particular index in prefix XOR array. And if left is not 0, then we will be looking just one entry before that to nullify effect till that point. Okay, and we will be entering that result into our result array, and then simply be returning that results array. Okay, now let's have a discussion about the complexities. So time complexity wise, see, uh, let's say the size of the array is a or m. Okay, and size of the queries array, although it will be, less than or equal to m, not exactly less than equal to m. So let's say the size of queries array is 2. Okay, so see, for doing this particular loop, you will be using order of m time complexity, which was the size of the array. Okay, and for processing all the queries, you will be doing order of q. Okay, so overall time complexity becomes order of m plus q. Okay, and space complexity wise, since you are using this m is equal to, let's say, size, so space complexity wise order of m only. Okay, these are the complexities. So if you are still having any kind of doubts or any queries in general, then you may ask them in the comment section, and I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.